Hi, welcome to this talk. My name is Philippe Fournier-Viger from the Harbin Institute of Technology in Shenzhen, China. Today I will talk to you about data mining. I will present a new algorithm to find patterns in the data, to find some rules in a sequence of events. So our goal is to understand the data and find some rules that will tell us about if some events happen, then some other events will happen later. So we call this the partially ordered episode rules, and we want to discover these patterns in some sequence of events, some event sequence. Okay, so let's start. So I will give you a brief introduction in case you don't know maybe about pattern mining, the field of pattern mining. So our input is a sequence of events with timestamp, as you can see on the picture here. So we have different timestamps like T1, T2, T3, T4, and we have some events like A, B, C, D, and so on. So we have C followed by AB followed by D, A, C, B, D, and so on. So if we look at this data, we can find that there are some relationship like AB is followed by D, AB again is followed by D, and so on. So to find these kind of patterns in the data, we can use some algorithm to find the frequent episode. That means some sequence of events that appear many times in our input sequence, in our data. So for example, I will show you one here. AB followed by A. Okay, so AB together, the event AB followed by event A. So we can see on top we have AB followed by A, and AB again followed by A. So this can be considered as a frequent episode because it appears many times in our data. So to find the frequent episode, we need to have a sequence like this of events with timestamp, and we need to set a parameter, the minimum support. And we want to find all the episodes that will have a number of occurrences that is at least greater or equal to this minimum support. So here, if we say we want to find the episode appear at least twice, then maybe we find ABA because it appears at least twice. So there have been a lot of algorithms to find episode in a sequence of events, like WinPy, MindPy, Emma, MinPy Plus, and many others. And there are also different types of episodes that we can find in a sequence of events. So all of this is interesting, but sometimes maybe we want to do prediction, or we want to predict or understand the relationship between events. So there is another type of patterns we can find in a sequence of events called the episode rule. So if we have a sequence of events as I shown to you before, we can find rules like this: X imply Y. So if some events X appears, then it will be followed by some other events, some other sequence of events Y. So for example, maybe we can find a rule like this: if we have A followed by C followed by B in that order exactly, then later we will find the event D. So here we can see in our example sequence we have A, C, B followed by D. So this rule appears in the sequence above. So if we want to find the rules like this that are interesting for the user, usually there are two main criteria. The first one is the minimum support. We want that the rule like this appear at least some minimum number of time to remove the noise. And also we look at the confidence, like the conditional probability. So how many times we have D, ACB followed by D, divided by how many times we have ACB. So if we have a rule X followed by Y, how many times we have X followed by Y divided by how many times we have X. So we want a rule that have strong, high confidence. And also we can set other constraints like a window size and many other things. Okay, so there have been a lot of papers about this, how to find the rules in a sequence of events. So like the frequent episode rules or other types like utility-based rule, precise positioning rules, essential episode rules, and many other published also in good conference and journals in data mining. However, all these works have an important limitation. It is that the episode rules must follow a very strict ordering. So for example, all the rules you can see on the left, they contain the same events, A, C, B, or ABC, or BAC, BCA, and so on, followed by D. So all these rules are very similar, but they have a slightly different ordering. The same events, but in different order. But for many applications, this is a problem, because maybe all these rules are the same. So for example, we could define a rule that is more general, like ABC in any order is followed by D. This will be more general than all these rules that you can see on the left. So this is our goal in this paper. Instead of finding so many rules that are almost the same but just a different ordering, we want to find some rules that are partially ordered. So we just say ABC in any order is followed by D in any order. Okay, so this rule will be more general and can summarize many other rules. So let me give you some definition, and then I will talk to you briefly about our algorithm and about the experiments. So here, one first definition is what we call an event set. It is a set of events like ABC, for example. So these events don't need to be at the same time, but they need to appear within maybe some window in the sequence. So for example, if we look at ABC, we can find we have CAB or ACB or ABC, but all of this we have ABC together. Okay, so we can say that these occurrence of ABC, all of these are occurrence of ABC, what I have highlighted here, okay, in the red boxes. Okay, so we say that an event set ABC can have some occurrences, we say non-redundant occurrences, like T1 to T2, because from time 1 to T2 we have ABC together, T5 to 7 we have ABC together, and T10 to T10 we have ABC together. So for some set of events, we want to find all the non-redundant occurrence. Then here there's something I need to say. Why we don't find T10, T11, for example? We also have ABC in the time interval T10 to 11. We don't keep T10 to 11 because it is redundant, because we have another time interval T10 to T10 that is smaller than T10 to 11 and is included in that interval. So we only keep the non-redundant, the smallest, that will not be included in another, okay, the non-redundant occurrences. Okay, now after we find the event sets that are have some and their occurrence, we can make some rules we call the partially ordered episode rules, where we loosen the ordering constraint between the events. So we want to find the rules like this: ABC imply D. That means ABC in any order, if we see them, it will be followed by D. So if you look at our example above, we have ABC in any order, maybe not at the same time, are followed by D shortly after. ABC followed by D again. So to find these rules, we suggest to use some parameters, the minimum support. we want to find the rules appear at least 3 times. The minimum confidence. And also we have some constraint on the time for the left part of the rule, the right part of the rule, on the duration for the occurrence. So we have X span, that means the duration of the left part of the rule. Y span means the duration of the right side of the rule. And XY span means the time between the left side and the right side of the rule. So at the bottom here I have a picture. We have the X span, that means the time for the left part of the rule. XY span, the time between the left part and the right part. And Y span, the maximum time for the right part of the rule. So we want to find the episode rules like this. Okay, so let's continue. So we define an algorithm called POERM. That first, what it will do, I explain just the main idea. It will find all the left part of the rule, the antecedents for the minimum support like A, B, C, and then it will grow these set of events to make some larger set of events like AB, AC, or ABC, and so on. So this is a recursive process. We scan the sequence and we try to make the left part of the rules. Now in the step number 2, after we find the even sets for the left part of the rules, we find the consequent to append them to the left side of the rule to make some rules. And then we repeat this to find all the partially ordered episode rules. So I will skip the details because we don't have a lot of time. And we also have a baseline algorithm we call POERM all. It will find all the possible antecedent and consequent and combine all of them together and filter to find the valid episode rules. So this is our baseline. So we did some experiment. We used some common public database, and we use the same parameter value for all the algorithms. So here I will go faster. Okay, so we did some evaluation in runtime, and for different parameter value we have the time on each database, like fruit hot, retail, and so on. And we find that our algorithm POERM is usually better than the baseline. We also did experiment for about the memory. We find that in general the POERM algorithm is faster than the baseline, except for retail because it is a sparse database. Okay, so using our approach, we don't save a lot of time compared to the baseline on the sparse database. We also find the real patterns in the real data. So here in the real shopping data, we find patterns to tell us about what the people will buy in a store. So this is really interesting to find the real pattern. So in conclusion, we define a novel type of rule called the partially ordered episode rules, an algorithm called POERM to find these rules quickly, and we did some experiment. We also have some future work to do the big data or streaming data for this algorithm. And also you can find the source code and dataset in our software. Thank you.